We're going to review the quadratics chapter in this section. Let's start with the warm-up. Achilles has an initial vertical velocity of 20 feet per second and a release height of 6 feet. So I'm going to underline that. Oops. Write the equation that represents the height of his ball over time if gravity has a downward acceleration of negative 16 feet per second. All right, so here's what it looks like. Negative 16, I use t for time squared, plus his initial vertical velocity 20t, plus his initial height that he throws the ball from 6 feet. So far this week we have looked at the following topics that we will review today. How to find the vertex, changing from factor to standard, general form, which means the same thing, vertex to standard or general form, and a basketball application. So first of all, how do we find the vertex? If this is the Achilles equation, when will the ball reach its highest point? So if we draw a picture of what that looks like, Achilles would throw his ball from 6 feet, it would go up and then go down. So we're looking for the vertex, and we're looking for the x value of the vertex. X is time, and y would be the height at that time. All right, so if you recall, to find the vertex, x equals opposite b over 2a. Achilles' b value is 20, and his a value is negative 16. So you have negative 20 over 2 times negative 16. So we get negative 20 over negative 32. So let's calculate that. Negative 20 divided by negative 32. So Achilles' ball will reach its highest point at 0.625 seconds, so in less than a second. Find the height of Achilles' ball at the time. We're going to take this number and plug into our original equation. So y equals negative 16 times 0.625 squared plus 20 times 0.625 plus his initial height, 6. So let's type that into our equation, or into our calculator. Negative 16.625 squared plus 20 times 0.0625 plus 6. And here's the height at that point. Oh, I typed something in wrong because it shouldn't be 1. It should be higher than that. I put an extra 0. So let's redo that. Negative 16 parentheses 0.625 squared plus 20 times 0.625 plus 6. All right, so 12.25 would be the height that his ball reaches at the vertex, the highest point. Okay, how do we change from factored form to standard/general form, which means no parentheses? These mean the same thing. You just multiply it out. So first of all, let's look at the roots. The roots are where does it hit the x-axis. So one of them is easy to see, it's negative 8. But the other one we have to make an equation. 4x minus 5 equals 0. We're going to add 5 to each side. 4x equals 5. Divide by 4. So x equals 5/4. So these are the two spots that your graph crosses the x-axis. Those are called zeros or roots. Now change it to standard form, just means multiply it out. So let's change colors here. We have 4x minus 5 times x plus 8. That'll be 4x squared minus 5x plus 32x minus 40. And if we write that out, we start with the highest power, highest exponent, 4x squared. Combine like terms, 32 minus 5 is 27. And then we have our minus 40 sticking out there at the end. So this is standard form. It means no parentheses. Okay, next, can you change from vertex to general form? Order of operations, we're going to multiply this out first. Oh, first of all, what's the vertex? Well, it's the opposite of what's in the parentheses, but the outside stays the same. So here's the vertex. To change it to standard form, first we multiply x plus 3 times x plus 3 and we'll get x squared 3x, 3x, and 9. And so if you write that out and combine like terms, look at x squared plus 6x plus 9. But then remember you have this minus 6 hanging out there at the end. So our final equation, x squared plus 6x plus 3. Okay, and basketball application. When will Achilles' height reach a ball of 10 feet, the height of the basketball hoop? So we know that here's Achilles. He's throwing that ball. It's going to go up through the hoop and then down. So let's say this is our hoop right here. It's going to reach that distance twice. And so in order to do that, let's clear this. We're going to write his equation. Negative 16t squared plus his 20t plus his 6. We want to know when that equals 10 feet. Let's get 0 on one side and use quadratic formula. So minus 10. We get negative 16t squared plus 20t minus 4 equals 0. And then use quadratic formula. X equals opposite b. So I should be a minus here. Ugh, that looks terrible. So opposite b plus or minus the square root of b squared minus 4ac all over 2a. Calculate our three numbers. X equals negative 20 plus or minus the square root of, we got 20 squared minus 4 parentheses negative 16 negative 4, 144 over negative 32. Let's break it up and find both answers. So the first one I'll do negative 20 plus the square root of 144, which is 12, divided by negative 32. So the first one's relatively quickly. It's after 0.25 seconds. And the other one will be negative 20 minus the square root of 144, which is 12, divided by negative 32 after 1 second. All right, so it reaches the hoop after 1 second. When would Achilles' ball reach the ground if he missed the hoop? So again, that's quadratic formula, but this time we use the original equation, which would be this. Negative 16t squared plus 20t plus 6 equals 0. So again, you would find a, b, and c and use quadratic formula to solve. So this one I'll set up for you and you can solve. X equals opposite b plus or minus the square root of b squared minus 4ac, all of that over 2a. And again, you can calculate like we did, and this should be a 20. It looks funny, 20. So all of that you would calculate, and you would get your two answers when it would reach the ground. And here only one would be positive, so it'd be the positive answer. All right, so there's a quick review of the quadratics chapter.